Hello and welcome to our video all about bearings. Bearings are an accurate way that we use to communicate direction to another person. The types of people who might use this would be captains of ships to help with their navigation, aircraft pilot. Now you should be familiar with normal bearings already, which would just use our usual north, south, east and west compass points. You should hopefully also be familiar with the ones in between, so northeast is in between here. More about true bearings, which is a more exact way of telling someone which direction you're in. So I've got this lovely diagram of a number of true bearings, and you can see we've got north heading up, south heading down, and the true bearings are the numbers that are attached to each of the bearings. So what you notice with the true bearings is that they are measured, they're angles, they've all got degrees on them. They're always measured clockwise from north. So we start at north and go this way. Let me put an arrow. There we go. An arrow going around. Has to go this way, can't go this way. Okay, that was my dog Rex, who just wanted to make sure that you were really clear. He agrees. Make sure you go clockwise when you're working out bearings. The second dot point I've got here is that all bearings are written using 3 digits. I've written that there and I want to highlight a few for you. Well, these ones down here, for example, 180 degrees. It's quite easy to see that's 180 degrees. It's got 3 digits, so we just write it straight like that. 135 also works pretty clearly, but when we get down here to 90 degrees and 45 degrees, you just need to make sure you put that leading 0 on the front there. Same with 0, you write 0, 0, 0 degrees if you're going totally 100% north, not going off to either way. So I'll give some examples here. For example, 045, you always write the degrees on there as well, or 090 degrees. The other thing that's interesting to note, might help you when you're solving a problem, is that the difference between opposite directions on our little diagram here is 180. So if you take 315, for example, and opposite that is 135. So we go 315, because difference means take away or minus. 315 minus 135, and it equals 180. First example here is asking us to find the true bearing, which is what this is all about, of A from O. So we're looking at A from O. It's really important the order that you use here. Another way this one could have been written is, or the true bearing from O to A. The from one is the one you're looking for. From O. These two are the same question. If it says from O, start with O, looking towards A. Our diagram's already been sorted out for us here, so we can see that. What we need to do is play around with our diagram a little bit, and we know that going all the way from north around to east would be 90 degrees. But we're only looking for this little bit in here, which I'll do in blue. So that little blue bit, I'll make it theta, because if we've got an unknown angle, we'll like to call it theta. Theta will equal 90, which is the full area, angle, minus the 30 degrees. And it equals 60 degrees. But we're asked to find the true bearing, so we need to make sure we've got 3 digits there. So we need to add the leading 0 there. From O to A. Okay, second example is exactly the same diagram, but this time we're looking at the bearing of O from A. So start with A and you're working out where O is. Again, from is the word we're looking for. Another way we could have written this is, or the true bearing from A to O. Same question, these two. Okay, from A, so we start here. If there isn't one drawn in, it's a good idea to put a north line in so you can see it clearly there. And then if we also jot in a south line going down here, we can see that it's going to be, because it's always from north, so it'll be this much all the way around there, plus a little green bit in here. So I'm going to make the blue bit, actually, hopefully you can see that the blue bit is 180 degrees, so we don't need to give that a letter. I will give the green bit a letter, and we'll call that theta. How can we work out this little angle? We've got this one, but we don't have this one. Well, if you have a look here, we can see that's a right angle triangle, or it doesn't even have to be right angle, but it is a triangle, so all of the internal angles will add to 180. So we've got 90 plus 30, which is 120. So if we do 180 minus 120, where's my green? Theta equals 180 minus 120 equals 60 degrees. So this green bit in here is 60. But we're trying to find our true bearing from A to O. So all the way around here, so we need to do 180 plus the 60 again. So I'll shorten it. True bearing will equal 180 plus the green, which equals 240 degrees. Last thing, check if you've got 3 digits, and we do, so we don't need to add a leading 0 on there. This one's a little bit trickier, but still possible. Example 3 is asking us to find the true bearing of A from O. Start with O, draw in your north if it's not there, and they have drawn it for us, which is great. We know this first bit is 90, and we need to find this little bit in here. But we know this little bit is 18, and we know the whole quarter there is going to be 90. So we can say theta equals 90 minus 18, which is 72 degrees. So we need to do 72 degrees plus 90. True bearing equals 72 degrees plus 90 degrees. Last thing for a true bearing, check if it has 3 digits or not. And this one does, so it's fine. Example number 4 is a bit more complicated worded problem. We've got 2 points, A and B, which are 15 centimeters apart. Label that on the diagram. B is on a true bearing of 100 from A. There's the from word again. Start with A, and B is on a true bearing of 100. They've labelled it for us, which is great. Find out how far east point B is from A, correct to 2 decimal places. Okay, part A. We need to, so how far east point B is from A? It's asking you just the easterly length, which is going to be this length up here. It's not asking you for the diagonal, it's asking you how far east, so it would be that one there. So we can label that as X, and we've got ourselves a little right angle triangle here that I'm going to redraw. We need to work out what this little angle in here is. We know the whole thing is 100. We know the quarter is 90. So this little bit's going to be 10. So I can label this as 10 degrees. This is the side we're trying to find out. And this side is 15 centimeters. So using it is a right angle triangle, so we can use SOHCAHTOA. First step is to label the sides. I'll label the hypotenuse, label the opposite, label the adjacent. And we've got the hypotenuse and adjacent here, so we can use cos, adjacent and hypotenuse. First step, always write out the full formula. Second step, substitute the values in. 10 degrees equals X over 15. We can move this 15 over the other side. 15 cos 10 degrees equals X. Put this into your calculator and we get X equals 14.77 centimeters, because the centimeters were up here. 2 decimal places, done. Part B is asking us to find out how far south point B is from A which will be this distance. So we can redraw this triangle again. It's a good idea to redraw it so you don't get confused with all your labeling. This is now the side we're trying to find. This is still 15. You could label this side is 14.77, but we don't need to. Forgot to label the angle. Opposite, adjacent, hypotenuse. This time we've got opposite and hypotenuse. So we can use sine theta equals opposite over hypotenuse. Sine 10 degrees equals X over 15. 15 sine 10 degrees equals X. X equals 2.6 centimeters, because it's in centimeters here. If we go back to the question, it says correct to the nearest millimeter. So I need to change this into millimeters, times it by 10. 26 millimeters. Thanks for watching this video on bearings.